In this video, we are going to talk about one of Snowflake's most useful performance feature, that is asynchronous functionality. By the end of this video, you'll have a clear understanding of what asynchronous execution actually means and how you can implement it in Snowflake using real examples. Now, let's start with how things usually work. When you run queries inside a Snowflake stored procedure, they run sequentially. In simple terms, this means only one query runs at a time. The next query starts only after the previous one finishes. And while this approach is straightforward, it's not always efficient. This sequential execution significantly increases the total runtime of our workflows. Also, with sequential processing, we are not taking full advantage of Snowflake parallel processing capabilities. This leads to wastage of resources. To address this, Snowflake introduced a powerful feature called asynchronous functionality. Using asynchronous functionality, we can submit multiple queries at once without waiting for each one to finish. This helps us to reduce overall execution time and makes much better use of compute resources, especially for the right type of workloads. Snowflake currently supports asynchronous execution mainly through two interfaces. One is through Snowpark API and the other is through SQL procedures. In this video, we'll walk through all the supported ways to implement asynchronous execution in Snowflake along with hands-on examples. Now, let's look at how asynchronous execution works in Snowpark. Using collect_novate function, we can execute multiple queries in parallel without waiting for each query to complete before starting the next. In this example, I am creating a table called asynctb and trying to insert 200 records into this table sequentially, and then after this I am reading the data from this table. Now let's see how much time this sequential execution takes to complete. So, if you see, the sequential execution took almost 58 seconds to complete. Now, instead of running these insert queries one after the other, let's use collect_novate function to run the queries in parallel. So, what collect_novate function does is it submits the queries to Snowflake and immediately returns control back to the program. It doesn't wait for the query to finish. This allows us to submit multiple queries back to back without blocking the execution. Also, one more thing we have to take care here is the collect_novate function doesn't track whether all the queries are completed or not. It just proceeds to the next query once it submits all the queries for execution. To solve this, we'll be using isDone function to check if all the queries are completed or not. So here what I am doing is I am collecting the query IDs of all these 200 queries and using isDone function to wait until all these queries are completed. So now let's run this and check how much time this asynchronous execution takes to complete. So if you observe, sequential execution took 58 seconds to complete, whereas by implementing asynchronous functionality, we are able to complete this in 11 seconds. So instead of running 200 queries one after another, we ran them all at once, leading to a almost 5 to 6 times of performance boost. Now, let's look at how we can implement asynchronous execution using Snowflake SQL procedures. In this example, I am creating a stored procedure called load data async. The goal of this procedure is to create three tables, that is customers, orders and regions, using Snowflake sample data. At the top, I declare three variables of type result set. These variables will hold references to the asynchronous jobs that Snowflake creates when the queries are submitted. Now, this is the key part. For each table, instead of running the queries normally, I am using async keyword. When Snowflake sees async, it submits the queries as a background job and immediately moves on to the next statement. So here, all these three queries execute at the same time instead of one after the another. After submitting all the asynchronous queries, we use await all function. This await all tells Snowflake to wait until all background jobs have finished before continuing. This step is very important. Without it, Snowflake would cancel asynchronous jobs as soon as the procedure ends. Once all queries are completed successfully, the procedure returns a confirmation message indicating that the parallel data load has finished. So let's create this procedure and then let's call this. So if you observe the query history, all three queries ran in parallel, which clearly shows asynchronous execution in action. Try running the same queries sequentially without using async and note down the total execution time. Then run this asynchronous version and compare the execution times in the Snowflake query history. This comparison clearly shows the impact of synchronous versus asynchronous execution and helps you decide whether async actually benefits your workload. Before you start using asynchronous execution everywhere, there are few important things to keep in mind. As we have seen in the examples, asynchronous works best when the queries are independent and don't rely on each other's results. In these cases, running them in parallel can definitely improve performance. However, if one query depends on the output of another, asynchronous execution can cause issues. In such scenarios, sticking to sequential execution is often the safer and more reliable option. Also, be mindful of your warehouse resources. Submitting too many queries at once can overload the compute layer and actually slows things down. Parallelism is powerful, but it needs to be used thoughtfully. So, to wrap things up, asynchronous functionality in Snowflake is a powerful capability for data engineers working with ETL pipelines and batch processing. When applied to the right use cases, it enables true parallelism, reduces end to end execution time, and makes better use of Snowflake compute resources. If you are still running all your workflows sequentially in Snowflake, this is definitely a feature worth trying. You may be surprised by the performance gains you can unlock with asynchronous execution. Thanks for watching, and I'll see you in the next video.